3.2 exponential and logistic modeling. So the only notes thing for this section is this one little formula basically for an exponential population model. If a population P is changing at a constant percentage or constant percentage rate R each year, then P of T is equal to P sub 0 of 1 plus R raised to the T, where P sub 0 is the initial population, R is expressed as a decimal, because R is originally going to be given to you as a percentage, so you just need to convert it to a decimal. And T is time in years. Now, that's generically, I don't remember if it happens in this book, but sometimes it'll be the time will actually be in days or something, but generically we would say that it would be in years. You just have to know if it asks you for something in days or something like that. Just that it's asking for that instead. Alright, so these first ones say to tell whether the function is an exponential growth function or an exponential decay function, and find the constant percentage rate of the growth or decay. So that's going to be finding R. So 2 P of T is equal to 4.3 times 1.018 raised to the T. So that's what's given to you. So the initial value is P0, which is 4.3. Then from our formula, 1 plus R is what's being raised to the T. So we're going to say 1 plus R is equal to 1.018. And then basically just solving for R. So subtract 1. So R is equal to 0.018. Now, to determine if it's growth or decay, we use that number. In this case, it's greater than 0. So therefore, this is an exponential growth function. With a growth rate of 1.8% is what that means. Basically, we just converted it back. I mean, it wasn't given it to us, but convert it to a percent, which is what R should be technically. Now, if our R value comes out to be less than 0, it would be decay. So that's not really in the notes, but it kind of just comes up as we go. So, anyways. Let's see. Another one. 6. G of T is equal to 43 times 0.05 raised to the T. So they don't specifically ask for the initial value of these, but it's good to just go ahead and just like get the practice of knowing what everything is. So that's why I write it out. So P0 is 43. Then our 1 plus R is equal to 0.05. So what does that mean R is going to be?
Negative 0.95.
Negative 0.95. And that would be less than 0. So what is this? So this is going to be an exponential decay function. And that means we don't say it has a growth rate of negative whatever. We say it has a decay rate of 95%. Okay, so the negative is purely just telling you that it's decay. We call it a decay rate, and we take the negative off. So a decay rate of 95%. All right, so pretty easy so far, right?
So for decades, we're taking the whole decimal and making that percent, but for growth, we're just moving the decimal over to after the first,
No, we still moved it over 2. So like multiply by 100.
Oh, okay. I got it.
So yeah. Just like you would normally change a decimal to a percent, just multiply by 100 in every situation.
Okay.
It just was based on the number that we had. That's why it happened that way. All right, the next ones are almost like little mini word problems, but they're like one sentence. Okay, so we're kind of doing the reverse. So they're giving us like an initial value. They're going to tell us if it's increasing or decreasing, which is going to tell us if it's like basically growth or decay. And then they're going to tell us the rate at which that's happening. We might get to where they give us some other information as well. But to start with, number 8, they tell us we have an initial value equal to 52, and then they say increasing at a rate of 2.3% per day. So this says increasing, so what does that tell us? So this is going to be a growth. Initial value is 52, so that means P0 is 52. So I kind of like to like write out everything that I know to start with before I actually try to just like throw it into the formula. Once you get a little more comfortable with it, you can kind of just go straight to the formula if you want to, but I just like to make sure I know what everything is going in. R is 2.3%, okay, but I need to convert it to a decimal, so R is going to be 0.023. So do the opposite, divide by 100, move it over to the left 2 places, however you want to think about it. But I know that when it goes in the formula, it's 1 plus R. So I'm going to go ahead and do plus 1, plus 1. So I would have 1.023. And so then all I need to do is write the formula for it, which is P of T is equal to the initial 52 times 1.023. And I like to do the parentheses most of the time instead of the little like dot like they did. So like the way I wrote them up here is exactly how they are in the book. I just like them written like this. I think it's easier to see because when you have decimals, especially when there's not like a 1 in front, it just makes it easier to see. And then we just raise that to the T. And that's all these ones are looking for.
So does it make a difference if it says per day?
We would just know that T is in days for this one. That's where I was saying earlier, like generically we say it's in years, but whatever like unit they're telling us, then it's that. Now, sometimes they will tell you, they give you something in years, but then in the end, they ask you for, like, how many days would this be, or vice versa. It's usually the opposite. You'll get some like exorbitant amount of days, like 100,000 days, and it's like, how many years is this? So then you have to like convert it, Anyways. Number 10. Initial value is 5, decreasing at a rate of 0.59% per week. So this one would be, if you were actually solving for T would be in weeks, is what that's telling you. But we don't have enough information to be able to solve these at the moment, so. All right, so what kind of function is this one going to be? Decay, because it's decreasing. P0 is 5. What would R be? Not R plus 1, just R.
Negative point. Negative point 0 0.059.
Okay, wait, where?
So point.
Say what you're saying again. I think I know where you were trying to go with it. It's not where I thought. That's why I said no.
Negative 0.0059.
Yes.
That's a lot.
I thought you were trying to give me like the final thing, and that's why I kept saying no. And then I was like, wait a minute, he might be trying to give me R, and going ahead and putting the negative on it. So yes, that's fine. So it's R plus 1. So now add 1. Anybody know what that is off the top of their head?
0.41. That's just a random guess there.
Well, you almost had it.
0.9941.
0.9941.
Oh.
So close.
It's like you got the hard part at the end, just not the 0.99 at the beginning.
So
I see
why
it now.
was it negative when he did it?
Because it's a decay.
Okay, so it's just automatically like.
So it said it was decreasing, so that's why it was negative. I thought he was trying to go toward, like, to say what the one, like, the plus 1 was, and I was like, no, don't do that. Then I was like, oh, I know what he's doing. So now when we put it together, P of T equals 5 times this number, 0.9941, raised to the T. That's it for those. Or for that one. Okay. I'm gonna do things out of order for how I normally do them.
Oh, yeah.
Just because, well, not out of order. I mean, there's problems are still going to be in order, but I usually teach something and then I come back to some of these problems that look a little different, but I'm going to go ahead and do these while we're on this train of thought. So these are still like I said, little mini word problems. Number 16, the initial population is 250. Oh, I think I know why I sometimes do the other one first. We'll go ahead and do this. It's not hard. And it's doubling every 7.5 hours. So this now means that T is in hours, okay? It's the only difference with this. This is going to look a little different in how we set it up, because this no longer is going to be in this form, okay? Because we're now told that we are doubling, okay? Which means that what we normally had here as 1 plus R is going to be just the number 2.
And that would be because R itself is 1. And then we add the other 1.
basically. But
Whatever I
generically,
said is
just,
more complicated.
yeah, it's
I like
just two.
complicating things. It's kind of fun
So
sometimes.
we still have P0 is 250. It's doubling, which means 2 times as much, basically. So it's kind of like almost like 200%, and then changing that to a decimal kind of thing is kind of what's happening. But it's not being added to the 1. Anyways. And then every 7.5 hours. Okay, so that now adds a different level of something we haven't seen yet. So when we do these, we still have P of T is equal to the initial, which is 250, times, it's doubling, so 2 raised to the, now this is where it's different. People often just want to put a T here, but that's not it, because that would mean it's doubling like basically every hour. So every time we add an hour. But this doubles every 7.5 hours. So we're going to put 7.5 in front of the T. Now, one thing, the book uses X instead of T in all of these problems, so just more of an FYI for you. I use T because we're dealing with time. It's a lot easier to see, but anyways. The other thing is, what the book is going to do when they write this answer is they don't like to put decimals in an exponent. So the way they write this is 250 times 2 raised to the 2t, or well, they use x, over 15. Instead of,
I think that might end up with a different.
I wrote it backwards. Hold on. Well, hold on. 15 over that. That's what they do. I wrote it backwards. I would not do it that way. I would do it as 7.5t, because ultimately you're getting down to where you're, what will happen is once we set these up is you're actually going to be solving problems. There's no use in making it more difficult by putting a fraction. So I would just use the decimal, because once we get to solving it, you're going to need to be able to do it. And I know none of you really like fractions all that much.
Just those two.
None of you really like fractions all that much.
It's like more than half of us, though. Exactly.
I mean, they're alright. A little intimidating, but alright.
Alright, 18. So this is going to kind of be the opposite. Initial mass is 17 grams. And it says it's halving once every 32 hours. Hold on a second, I need to look at something. 1 minute. I think I might have actually done the last one backwards, so I'm trying to look at something really fast.
I was also thinking something was a little odd, but I wasn't sure, so I wasn't saying anything, because I don't know.
These ones are always weird, which is why I said I realize why I normally do this in the other order, because normally I've already explained this in a different problem, but I like to try to keep the stuff in order and do all of these and then do the word problem, so that's why I was like, wait a second. I don't have one like that. Okay, yeah. This is supposed to be either t over 7.5 or 2t over 15 because it's in hours. So it's like dividing it in a sense. Oh, yeah. Anyways. So this should either be t over, not wrong color. T over 7.5, or that's why they have the 15t over 2.
You wrote it backwards again.
Huh?
You wrote it backwards again.
This is how you know we're ready for Christmas break. Okay. I will verify that again and let you know if something is wrong, but anyways, okay. Which will make these next ones make more sense now. Okay. So then now we have an initial value of 17 grams, okay, or 17. It's halving, okay. So there's, again, 2 ways you can write this, and then it's every 32 hours. So this is going to be t over 32. So it's going to be P of t is equal to 17 times, you can either do it as 1/2 raised to the t over 32, or P of t is equal to 17 times 2 raised to the negative t over 32. Okay, the book will do it this way with the negative exponent so that they don't have a fraction like within the actual thing. But that's what is, or how it's written, because it is having it. All right, I'm going to go back and do the other word problem that I would normally do prior to this and solve it, and then that will probably help make things make a little more sense with how this is all going to come together at the end. Okay. Suppose a culture of 100 bacteria is put into a petri dish and the culture doubles every hour. Predict when the number of bacteria will be 350,000. So basically, we're now going to be solving for t. We're trying to figure out how long it's going to take. Now, notice it doubles every hour. So that means that what we're dealing with is going to be hours now. So our initial P0 is 100. Okay, now that means that's what happens at 0 hours. It doubles every hour, so that means at 1 hour, there's going to be basically 200, because that's going to be 100 times 2 raised to the first. Then at 2 hours, it's going to double again, which is going to give us 400. Okay, and the way we get that is we have 100 times 2 squared. Then at 3 hours, okay, and I'm being a little dramatic. I would not actually write all of these if I was just doing this problem, but I want you to see how we get what we get. I double that number again, so that's going to be 800. So how do I get there? 100 times 2 cubed. So generically, how might I need to write this for just P of t?
Times 2t.
100 times 2 to the t. So that's like the generic formula for how I get there. Okay, I could keep going, but normally I would probably just do one, maybe two of them if I was trying to figure it out. Once you get a little more comfortable, you won't even need to do that part, but for right now, it's good to have that. So I want to know when the number of bacteria will be 350,000. So this number here is P of t. So I'm going to have 350,000 is equal to 100 times 2 to the t. Now, this is where I don't really like how this book does this. I understand why they teach this section after the section we just did, but the section that comes after this is actually needed to solve this. So I'm going to give you a little intro because I don't remember if we actually got to do anything with logarithms at the end of last year. Sometimes I get to it and sometimes I don't in Algebra 2. So I'm going to do a little refresher if you've seen it before. If not, you're going to see it for the first time and you're probably going to be really confused, and I'm probably going to need to teach the next section for you to actually go back and do these word problems. I think that's what normally ends up happening. I think I actually teach the next section and come back and do the word problems. But nonetheless, this is what we're doing right now. So we divide by 100, so that just takes 2 zeros off over here. So that's going to be 3,500 is equal to 2 to the t. Now, I rewrite it, and you'll see why, because of the method that I use to solve it. We have 2 to the t is equal to 3,500. So I have an exponential, but I need to be able to solve it. I have no idea of 2 to what power gives me 3,500, right? Like, do you know what that is? Because I don't. So I undo an exponential with a logarithm. And if you have a logarithm, you undo it with an exponential. So what we do is I draw an L, okay, which is going to be log base 2 of 3,500 is equal to t. And at this point, again, you still don't know what log base 2 of 3,500 is, but fortunately your calculator does. So if you get out your calculator, under math, I believe, and I think it's like alpha A or something like that, or you can just arrow down till you see it. It'll say log base, and base is written like really big, kind of obnoxious. It'll bring up a log, and then it'll bring up a little box and then another box, and you just fill this information in, and it'll come back and tell you what that's equal to.
11.77.
Now, it said it doubled every hour, so what units would go on this? Hours. Were y'all able to get it in your calculator?
How do you do it?
So you go to
Okay, hit math.
It's a big button.
And then I think you just have to arrow down till it's like alpha A or something, but
Log base.
yeah, log base, and it's like base is obnoxiously large written, at least on mine it is. And then on there, you'll need to, it'll bring up like a log, and it'll bring up the little box, which is what the 2 goes in, and then it brings up another box. You just kind of have to arrow between the boxes and put in the 3,500 then.
Got it.
Now, who knows what 0.77 of an hour is? Okay, so that's what I thought. So
A little
we...
over 3/4 of an hour.
Okay, well, yes, we do know that. So we like to make things into something that people can actually understand, okay? And I would say more than likely, if you get a question like this on the AP exam, they're not going to ask you for it in exact hours. They're going to want something that's a little more understandable, Okay, at least knowing what they look for with calculus 1, I'm assuming pre-cal will be a similar one. So we take this 0.77, so we know what 11 whole hours looks like, we're good. We just need to know how many minutes that 0.77 is. So we have 0.77 hours, and we multiply that by 60, because that's how many minutes are in an hour. And what does that give you?
46.2.
Okay, so we're just going to say 46 minutes, basically. So the way I would actually end up writing this is 11 hours and 46 minutes. Because that is something everyone can understand. 0.77 hours is not something everyone understands. It's also pretty wild that in 11 hours and 46 minutes you can go from 100 bacteria to 350,000 bacteria. Just in case you were so interested in how that works.
You're wondering.
I think we'll stop there, but what I'm going to do is I'm going to go ahead and give you a few problems based on what we've done, and then tomorrow we'll wrap up with some two half-life problems because they work the opposite way, so kind of looking at like, you know, I think it's like carbon dating or whatever, and they like take the half-life and they figure out how long it's been in the earth, and you know, it's all wrong, but they do it anyways. So we'll look at those problems tomorrow, but it's not worth trying to start it with like 5 minutes left. So 1, 5, 7, 9, 13, 15, and 17, you might still be a little confused about those. I need to look and probably do another one of those for you as well, but anyways, just try what you can, and then we'll go through with the other word problems tomorrow.